Okay, so well, welcome to the talk. So I'm going to be talking a little bit about games technologies and how they apply outside of video gaming. I will be making use of the text chat because there's some points where I'll want your input. But since it seems like we're all here, I'm going to get started with there. Okay, so my name is Will Blewett, and I'm the course director for games technology at Coventry University in the UK. I like to give this talk because, well, basically because I sort of made this journey backwards. When I was, the age you are, and I was deciding what I wanted to do at university, computer science and games were often, sneered at and not necessarily seen as real fields. So, because, I was a strong and independent young man, when I said to my parents, I want to study computer science, and my mum said, no, you'll do physics, I did physics. I'm not going to say I regret the decision, but it does mean that I've got a bit of a roundabout perspective because I went from physics through artificial intelligence, computer science, and then background to games, where I realized that a big chunk of games was actually the bits that I most enjoyed when I'd been learning physics. The core reason for this talk is so that all of you can give your parents a decent answer when they say, but what can you do with a degree that's about games outside of video games? So, to start with, who wants to try and define a video game for me? Okay, I'm going to stop sharing while we throw that into the text chat. Sorry, Damien, how would you define a video game, right? Or how would you define a game? Okay, so we've got a lot of answers that are addressing, creativity, art, fun, relaxation, and all of those are true, right? Video games are an art form. They are relaxing. I'm sure a lot of us are getting a good deal more experience relaxing with them now than we're used to. But there's a bit more to it. A game, if we take a sort of dictionary definition of a game is a simulation with rules and victory conditions. And Tome, you're perfectly right. It does depend on the game. And yes, gaming is an emotional experience that you can learn from. When we're thinking about games technology, what we need to do is parse away everything to the point where we can define it in a simplistic fashion and then build on it. So the definition would be a simulation with rules and victory conditions. Now, chess is a simulation with rules and victory conditions, right? It's a war game. The rules are very straightforward. The victory condition is the king needs to be caught in check and unable to move into position where they're not checked. Now, if I turn the screen sharing back on, so as a function of Zoom, I can no longer see what you're typing, by the way, but I will periodically check the chat and see what's going on. So they are entertainment, but the engineering behind them is some of the most sophisticated software engineering in the world. Video gaming, computer gaming is what pushes innovation in the home computing sector. And nowadays, video gaming has pushed innovation outside of the home computing sector. And we're going to talk a little bit about some of those examples later on. The important thing is that gaming drives both hardware and software innovation. So the solutions that we come up with for simulating an explosion in a video game, that's a software solution. But those solutions that we come up with can then be used in other fields and other areas. And our understanding of them makes us uniquely placed to leverage them. Personally, I adore gaming. It is, when I'm not working, it is what I do. But sometimes why we came up with something isn't as important as what we do with it. There's an example. A couple of gents in America really wanted to keep we're talking the last century, so they still had coal fires. And they really wanted those fires to be, they wanted to clean the area around the fireplace. And they came up with a putty that they would just roll along the wall and it would pull the soot off with it. We now call that putty Play-Doh, because the real commercial value of it and what people found to do with it was a child's toy. Because shortly after they came up with it, people stopped using, or the use of coal for fires was significantly reduced. When it comes to games, the core things we need to understand are the engineering and the maths. But once we understand those, we can leverage that elsewhere. So, the core of gaming is high-performance computing, right? Every single gaming generation has pushed the boundaries of what the hardware can do in the context of basically how fast can we make the transistors flip and how much of the memory are we using. And there are lots of reasons behind that. When you're dealing with a console generation, you're looking at a platform that isn't going to change for 4 or 5 years. And by the time you're reaching the end of those 4 or 5 years, new technologies have come along that you want to leverage to make your game look better or make it more interactive, but you don't have any more resource in which to pull that, right? You're still looking at the same PlayStation 3 in 2012 that you were looking at in 2010. We don't really talk about the PS4 Pro, and yes, I'm aware that the current generation messed things about a bit. But by and large, the ethos is that once you've got hardware, that's the hardware you are developing for. And you might want to ask more of it, but if you're going to do that, you're going to have to invent a new way to get it to do it for you. The next thing, physics and maths. A lot of the things that we do in gaming come down to physics and maths. If you want to write a renderer, we're spending an awful lot of time doing mathematics on matrix manipulation. where we're basically transforming coordinate systems. So an object that is here is actually here and turned around this way, and so on. When it comes to physics, well, all games have physics. I'll talk a little bit about how games abstract physics later on, but all games, even text-based adventure games, have a given level of abstraction of physics. UI and UX, these are really, really, really important fields now, beyond gaming. So many applications now have user interactivity and augmented reality. So, as an example. So while augmented reality and virtual reality were originally seen very much as gaming enthusiast areas, you now need to think you could be developing an app for a social media platform, or a database app, or a stock taking app that the users are going to need to understand how they interact with it and see the information it's giving. So the stock taking app might tell them when they're looking around the factory how many units of something they've got. You need to think about how to get that information to them so they understand it and can react to it quickly. And game developers have a lot of experience with that, because everything that we do is designed to be an immersive experience that is conveying information to the players so they can make decisions. And then rendering technologies. But again, I've already talked about VR and AR, but those are just a couple of things that come out of video gaming. The cool background that you can't see behind me because the screen is not... Let me just, again, stop the sharing. Sorry, just while I'm stopping sharing, I'm having a little look at what's been said. What games do I play? I play WoW. I play a little bit of Dota. I play Overwatch, Counter-Strike Go, and an awful lot of Baldur's Gate. All of you might be too young to remember Baldur's Gate. It came out before you were born. Came out before some of my colleagues were born. But yes, role-playing games, first-person shooters, occasional survival horror. I have played Minecraft. I once wasted a huge portion of my free time over the course of 3 weeks building a scale model of the Parthenon. But when I was doing it, you didn't have white stones, so I was doing it with white cloth. And the problem with the Parthenon is that it has torches. So I started adding torches to it, and the next thing I know, the entirety of everything I've built is burning in slow motion across the survey map on the top right-hand corner of the screen. But yeah, so I have played Minecraft. My favorite game is Baldur's Gate 2. As regards why, it had a very... I was a Dungeons and Dragons player growing up, and Baldur's Gate 2 was a reasonable transliteration of the second edition rule set, and I really enjoyed that, and it had a very engaging story. Anyway, sorry, I am digressing. But not all popular games are based on competition and war. If you think about the most popular games that are played, they're things like Candy Crush. And that's something that you also need to think about in terms of game technologies. Are we talking about games that are interactive in the context of we're going to sit down and we're going to play this for 3 hours, or is it something that we're sat commuting, or nowadays stood in a huge queue outside of our supermarket 2 meters away from everybody around us, waiting to be allowed in to buy bread, right? Anyway, so back to the screen sharing. When I'm screen sharing, I can't see the chat text, so that's why I'm periodically swapping between. Right. So, real-world uses of video games. Anybody want to video game technology? Anybody want to pop into the chat some real-world uses they know of? So yes, pathfinding for GPS. GPS uses the A-star algorithm. Video games use, well, it doesn't always use the A-star algorithm. There are variations on searching and sorting algorithms that GPS uses, but all of them are used in video games as well. Sorry, I've put it in the I've written it in text. So real world uses for games technology, Vlad. Flight simulation, yes. For many years, one of the most popular video games in the world was a Microsoft Flight Simulator. Nobody entirely understands why, because nobody could play it. But it was very, very popular. That's life is a game or winning in life. That's a bit philosophical for me, I'll be honest. Yes, there are benefits to reflexes from video gaming, and A-star is an amazing algorithm. We can probably talk about that later on. Okay, so anyway, I've got some real-world examples, and for the rest of this talk, I'm going to be introducing you to them. Okay, and again, I will periodically pop in and check the text chat. Okay, so this is one of my favorites. Submarines. Once upon a time, submarines had, the way you saw out of a submarine was a huge pipe that had mirrors at the top and bottom, and you looked around through the pipe and you swiveled around, and that allowed you to see all the way around the submarine, just if it was just a little bit below the water. Now, modern submarines use what we call a photonics mast to replace that archaic technology. And a photonics mast is a webcam on a stick. It's slightly more sophisticated than that, but really it's a webcam on a stick. Now, for ages, the US military and other militaries around the world still kept that very cumbersome control device, despite the fact that it was attached to a webcam on a stick, and there was no physical link, no mechanical link between the user and rotating of the camera. Does anybody know how they're controlled now? You aren't far wrong, Valicia. They're controlled now by an Xbox controller. Well, the US Navy realized that we spend an awful lot of time training people how to use this big, cumbersome viewing device, when actually you could just do it all with the Xbox controller, and all of them can already play Call of Duty. Now, drones, it's the same technology, right? Same principle. You'll notice, nowadays when we talk about drones, we're talking about something that you can walk, well, that up until the plague, you could walk onto the high street and buy, for far less money than you would expect. And you can control them just the same way with the Xbox, with something that looks very much like an Xbox controller or a DualShock controller that's had the serial numbers filed off. MIT also found that video game players were better suited to be drone pilots than pilots. And the reason for this is that video game players are very used to the idea of the entire world being a camera that's hovering and you are turning it around like that. Video gamers aren't used to this idea of forward momentum to turn through something, like, unless you are like the person in the chat who plays Microsoft Flight Simulator, actually good at Microsoft Flight Simulator. So, why do they use this technology? Well, as I said, when we're talking about the US Navy, they knew that all of their submariners could play Call of Duty, right? Or something similar. So they were familiar with this handset. But there are other bits, like the ergonomics of video games controllers have been refined by hundreds of millions of people. You know, we are no longer in the dark days where a video games controller was a rectangle with very sharp corners that cut your hand as you pushed A or B. Nowadays, they are ergonomic in design, and they've been refined over multiple generations, with each hardware generation replacing, slightly tweaking the controller based on user feedback. Now, if you were going to do that as a research project or a military project, you would be talking about tens of billions of dollars of investment just on the research. Somebody else has already done it for you, and their customers were paying to be your guinea pigs. Of course you're going to use it. Just quickly glancing at the chat. So, what's next on our, what's next? Okay, so how about medical applications of games technology? Way back when I was a young, recently graduated doctor, so I just got my PhD, I was working on serious games. So games that would help students, children, recover from illnesses. So they were rehabilitative. So it was rehabilitative gaming for school-age kids, using interactive storytelling and haptics to convince them to do exercises they had to do. It was for people who had children who had hemiplegia, so only half of their body was able to move fully. And the neuroscientists, I'm not a neuroscientist, the neuroscience was way beyond me. The neuroscientists worked out that if these kids exercised their good side, it could help rebuild the nerve connections on the side that was damaged. So they turned around to me and said, okay, we need you to make an interactive storybook that's going to get these children to do their exercise. Now, this was 2012, so we're talking before Tegra became a thing. So before you had GPU compute on Android devices, and it had to run on any Android device that would run Android 2.1. And it couldn't have any special hardware. It couldn't have paints on the fingers to identify where people were. It all had to be done in real time using a front-facing camera on hardware that nowadays wouldn't run a Diet Coke version of Excel. That was a challenge. And I was only able to do it, only able to address that challenge because I had high performance computing understanding from doing, work in game development. What I wound up doing was shuffling. GPU compute wasn't a thing, but shaders were still a thing. So what I wound up doing was shuffling all of the computation onto the GPU using shader code, and then returning the answer to work out where the hand was and if it was doing the wave motion, so on. So, that was fun. It was a challenge. It was an application of games outside of entertainment. And it was very rewarding when 6 months after I finished the project, they showed a video of children who were using the game and how it was improving their motor control. Now, here's something added just for this webinar: pandemic modeling. The corrupted blood incident in World of Warcraft is almost folkloric. Was anybody was anybody playing WoW when it happened? Let me just have a look at the chat. Yeah, there we go. Yep. Yeah, I know that. Yeah, I'm ancient. Thank you, Fane, for reminding me. But yes, two scientists, two epidemiologists, looked at the data that Blizzard had gathered over the course of the pandemic and analyzed it and published a paper 2 years later, which was addressing how you could use the behavior of the World of Warcraft players to model people's responses to a pandemic. And subsequently, that data their modeling has been employed very relevantly nowadays. Work in the areas continued based on modeling people rather than movement, because people are the wild card when you're modeling a pandemic, and you've got this huge online community, and they were making knowledge-based decisions and having knowledge-based transactions between each other to try and work out how to avoid being caught by the corrupted blood incident. By the way, what corrupted blood was, there was a dungeon added to WoW. A boss was added called Hacker, who had an ability called Corrupted Blood, and it could affect players and their player characters and their pets. And it didn't cleanse off pets when you left the dungeon, and pets could infect other players, who could then infect other players, and you wound up with basically a huge pandemic of people throughout World of Warcraft, of people who were infected by this or trying to avoid being infected by it, and some people who were absolutely, intentionally trying to infect other people because they wanted to see the world burn. Yeah, so I used CG or HLSL, Radu. I prefer GLSL, but the project had to be written in Unity, and in those days, Unity only supported HLSL, and that was problematic because the hardware we originally had to develop for had some issues when it came to blitting with HLSL. Anyway, we can talk about that later on. GLSL is the OpenGL shader language, Toma. It's what, so shaders are little programs that run on your GPU that decide what color a pixel should be. And GLSL is one of the languages that you write those in. Okay, let's continue. So another application of games technology in the real world related to pandemics is folding at home, right? The Folding at Home project came up with a client for PlayStation 3, or gamers involved with the Folding at Home project came up with a client for PlayStation 3 over a decade ago now. This client is what led to Folding at Home having GPU support, and GPU support pushed Folding at Home above the exaflop boundary this month. And the lion's share of that computational power is going towards actually trying to work out how the COVID virus, the coronavirus, novel coronavirus, behaves and how it moves on a molecular level, because that's how you work out how you're going to build a vaccine or a treatment that's going to intercept it. And Folding at Home, for those who don't know, is a shared computing platform that basically steals processor cycles from your GPU or your CPU if you sign up for it, and puts them towards modeling, basically biological modeling, helping us understand how cells work. And the majority of that computing power is powered by gaming at one remove. Exactly. It's like Bitcoin mining, but it actually has a real purpose rather than just killing the planet by burning carbon. Folding at Home isn't from NVIDIA, Damien. They support it. NVIDIA strongly support Folding at Home, and they've got a server dedicated to Folding at Home. But Folding at Home is actually it's a multi-university scientific project, and anybody can get involved. Accessibility. So a lot of companies do research into ways their games can be accessible for people who are handicapable. So Blizzard does a lot of work on how to let people who might be quadriplegic, for example, play Overwatch. Codemasters designed a bespoke user interface for a racing game that could be used without being able to manipulate the fingers. And these platforms were originally developed for gaming, but having been developed, they can then be applied to actual moving of, say, electric buggies or driving. So this is other ways in which gaming can directly influence and affect people's real life. Right, social media. This is where we get back to that philosophical question about whether or not life is a game. Well, social media is a game. We've already said that our definition of game is rules and victory conditions, right? Social media is fairly straightforward. The rules are you are attempting to make other people feel bad about their life. The victory conditions are you get more likes than they do. Sorry, that's a bit cynical. But social media is gamifying human interaction, right? You post something, you get likes. It's the equivalent of you punch a brick as Mario and you get a coin, right? The coin is meaningless. It doesn't directly affect anything to do with your ability to play Mario. But you punch the brick anyway to get the coin, in the same way that the rat taps the little lever that's going to give it some cheese. And social media is about leveraging that in the context of how humans interact with each other. In so doing, we provide them an awful lot of data, which they can then data mine, and there are ethical concerns there, but there are also potential benefits. Physics simulation. So all games have physics, even text-based adventure games. They just have a very, very significant abstraction of physics. So if you think about it, video game physics is little instants in time, right? Real world time is a continuous experience. Game physics time, you're looking at slices in that experience. Now, in something like Call of Duty, that slice is 120th of a second. But if we're going to say that, and what you do is you say, what were the positions of all these objects at this time? What will those positions be in 1/120th of a second? Right? If you're going to make that abstraction, you can look at something like Zork and say, well, all we're doing here is saying that the time chop is however many seconds it took me to walk from this room to the next room that is north of me. So yeah, all games have physics of some description. The bits that are really useful outside of gaming are the real-time elements. So things like Call of Duty or Crysis, if you ever manage to get Crysis running at a reasonable frame rate on something that's not a supercomputer. Video game physics sacrifices accuracy for speed. So in a video game, we don't need the explosion to be completely physically accurate. We just need it to be cool enough that we don't look at it. And there are scenarios in the real world where that sort of physics is valuable. So there was a research project I was involved with where people were, they were modeling trains. And they wanted to know, if you put a train on this section of track, is the train going to tip? Now, the traditional way of modeling that is called finite element modeling, and it is very expensive. What we said was, well, what matters really is identifying the cases that are definitely going to tip, and then we can focus on the cases that maybe won't. So we used NVIDIA's PhysX system to model trains as game entities. Threw those trains around corners and worked out if they were definitely going to fall over or just might fall over, and that pruned a good many scenarios that might need testing later on. Just have a look at the chat. Yeah, okay. Okay. High performance computing via games. So video games are written using what we call compiled languages. There is one notable exception, and that is Minecraft. But when Minecraft then was released for console, it was also written in a compiled language. Minecraft, when it originally came out, was written in Java, which is a non-compiled language. It's an interpreted language. What's the difference? A compiled language is where the instructions that you write are baked down into very simple instructions that tell the transistors on the CPU how they're supposed to flip, right? An interpreted language doesn't do that. An interpreted language looks at what you have said you want to do and then tries to work out itself how to do that on the CPU. So you can think of it as an interpreted language has an interpreter. So somebody who speaks the language of the machine and talks to the machine, gets information back from the machine, turns and talks back to you, you being your code, talks back to the machine, and so on. Compiled language, you are just making something that executes directly on the machine. And that gives you significant performance benefits because you cut out that middle person who was doing the talking. Now, video games development leverages that, and it leverages what we call heterogeneity. All computer platforms nowadays are heterogeneous platforms. Even my watch has a tiny GPU in it, as well as multiple CPUs. And that's all a heterogeneous platform is. It's a platform that's got more than one type of processor. Video games have always leveraged that for as long as they've been a thing, right? That's why the GPU was created, because video games wanted it. And a GPU and a CPU are completely different. We have to leverage all of them, and we have to do so in an efficient manner. And that is the heart of high-performance computing, as in high-performance computing research is all about leveraging the computational resource you've got as fast as possible. And game developers, people who are experienced in games technology, are very, very good at that. The Xbox One, the PlayStation 4 are basically Coke and Pepsi. They are both using almost exactly the same hardware, just clocked slightly differently. It's still an x86 octa-core CPU with some so CPU in the middle, memory, then GPU compute units on the outside. And because you have that architecture, you're able to port important computing tasks that might do better on the GPU to the GPU, and consequently get a frame rate increase. So you might move fluid simulation to the GPU. And by moving it from the CPU, though it's counterintuitive, you actually make the graphics run faster because they aren't waiting for the CPU to finish computing how the water should move in the first place. And yes, console games are generally coded on PC. They are deployed on dev kit consoles, but they are written generally on PC, yes. Full dive VR, you are limited by basically the interface device. We will continue to move closer and closer to photorealism to the point where photorealism isn't the limiting factor. The limiting factor is the interface device. And short of a matrix style directly interfacing with your central nervous system, you're never quite going to get something like the Star Trek holodeck. Okay, and we are literally finishing on the minute. So hopefully if you've taken something from this, it's that you have a good argument to give your parents when they say, but can you get a real job if you do games tech? Because you can. The games industry is generally going to be the destination of choice, but it is in no way a straitjacket. And hopefully this has given you an idea of the breadth of additional careers or alternative careers you could pick if you decide that you don't want to go into gaming having studied how to make games. Okay, right. Thank you all very much for coming. There is a Q&A tab that I'll be having a look at, and it has been a real pleasure.